Hi everyone, how are you? Hope you are doing fine. I know summer is at its peak. Stay hydrated, take water, fruits, all these things, take care of your health. Today we are going to discuss some hot numericals from the topic plane mirrors, from ray optics, from plane mirrors. Let's go to the questions. Actually, I am focusing on few questions from JEE mains, shift 1 and 2, both, okay? Let's go to the first question. Let's read the question. What is it? Two vertical parallel mirrors A and B are separated by 10 cm. A point object O is placed at a distance of 2 cm from the mirror A. The distance of the second nearest image behind the mirror A from the mirror A is. So the diagram is here. So we have to do this. Okay. So you can see a mirror A. This is the mirror A, the other one, the mirror B, another mirror, okay, near to that. And you can see an object O, which is kept at a distance 2 cm from it, okay. And the distance between this mirror is 10 cm. What is the question they are asking? From the A, the distance of the second nearest image behind A, from A. So already we know what is the distance of the first image. Where is the first image? You know very well. In plane mirror, U and V are same. Okay. Wherever U is there, the same distance behind the mirror image is formed. That is a property of what? Plane mirror. So let us see this one. So if it is 2 cm behind the mirror means this is the distance. This is the first image which is at a distance 2 cm. So this is the first image, I1. I can call it as I1. I can call it as the distance as D1A, distance to the first image, D1A, which is equal to 2 cm. This one already you know. But they are not asking about the first image. They are asking about the second image. How will you find out? Let's see. You can see this is O, and what is the distance of this mirror B from O? Which is nothing but together is 10, right? So here it is 2. So obviously this will be 8 cm. And do you know what is the image of this mirror? That is mirror B. It will be obviously behind it, and this will be the image. I can call it as I2, which is at the same distance because we know that U and B in same way. Okay. In the case of plane mirror, wherever you keep the object, same distance behind the mirror, you can get the image, right? So it's like 8 and 8. So they are asking what is the distance of the second nearest image behind the mirror A, okay? So from A, what is the distance? Look at this one. From A, this one is 2 and this one is 16. 16 plus 2, which is nothing but 18 cm. So what will be the distance? D2A, which is nothing but 18 cm distance. So 18 cm is the answer for the second nearest image for A, okay, from mirror A. I hope you understood this. Just go through the solutions. Go to the second question, which already asked for exam, JEE mains. Let's read the question. As shown in the figure, a plane mirror is fixed at a height of 50 cm from the bottom of the tank containing water, and mu, refractive index is given 4/3. The height of the water in the tank is 8 cm, and a small bulb is kept at the bottom of the water tank. The distance of the image of the bulb formed by the mirror from the bottom of the tank is, you had to find out, okay? That means distance of the image of the bulb formed by the mirror from the bottom of the tank. Look at this diagram. You can see the mirror is up. You can see this is the mirror, right? This is the mirror, okay? And this distance is 8 cm, and the distance from the mirror to the bottom of the tank is what? 50 cm. What you have to find out is what is the distance of the image of the bulb formed by the mirror from the bottom. That means this bulb will produce an image behind the mirror. Okay, so that image and from the bottom, what is the distance? Okay, so in order to solve this, we had to take the idea of real depth and apparent depth. You know very well what is the equation for refractive index, mu? Refractive index is equal to real depth divided by apparent depth. Okay, this equation already you might have studied in ray optics. It's one of the very important formula for many numericals. Okay, so from this you can get what is apparent depth. Apparent depth is equal to real depth by refractive index. What is the value of real depth here? Look at the diagram and it is 8. Okay, real depth is 8. So substitute that. Real depth is what? 8 by refractive index of water. Already we know what is the value, 4 by 3 or 1.33. Always prepare 4 by 3 for the problem because cancellation will be easy. Okay, so 4 by 3. So 8 into 3 divided by 4. 24 divided by 4, which is nothing but 6 centimeter. So what is the value of apparent depth? 6 centimeter. And let me tell you one thing, apparent depth from where you have to take. Always, you studied in 11th standard also, okay? Depth always you have to take from the surface. From surface to the bottom. So apparent depth is nothing but from this surface to the bottom means 6 cm. And still 2 centimeter is pending to the bottom. So apparent depth will be what? 6 centimeter. 6 plus 2, it becomes again 8. So what is the distance of the object from the mirror? Actually, this apparent depth, this image, it's not a real one, it's an apparent depth image. Okay, this will act as what? Object for the mirror. So what is the distance between this? Actually, how to get the distance from the mirror to this one? Okay, how will you get? The total distance is what? 50. So this will be like 2 centimeter away from the bottom, right? So what is the distance? What is the object distance? Object distance is nothing but, what is it? Total 50, you just subtract 2, which is nothing but 48 cm. I hope it is fine. Yeah. And another thing, if the object is 48 centimeter, again from the concept of plane mirror, you will get the image backside at the same distance, right? It's V equal to U. Okay. So if it is 48, somewhere it is 48 away from it. Okay. But the question is not that. What is the distance of the image from the bottom of the tank? That is the question. There is a small twist. Always read the question 2 or 3 times to make the answer proper. Okay, otherwise you will be like making some mistakes. Okay, so what you have to find out? 48 plus distance from the bottom. Bottom means what? You just take 50 centimeter. From mirror to the bottom, it's not 48, it's 50. So what is the distance? What they are asking? Distance is equal to 48 centimeter plus 50. 98 centimeter. So the final answer is what? 98. Hope you understood. So this is also from plane mirror, one of the tricky question which asks for JEE. Okay, just go through it. Okay, let's go to the next question. Let's read this one. A light ray is incident at an incident angle θ1 on the system of 2 plane mirrors M1 and M2 having an inclination about 75 degree between them as shown in the figure. Okay, after reflecting from the mirror M1, it gets reflected back by the mirror M2 with an angle of reflection 30 degree. The total deviation of the ray will be dash. Okay, it's really an interesting question. You cannot solve this until you are not completing the diagram. You should have a thorough knowledge about law of reflection and some angle properties. Okay, so let us go through the question, how to draw it. I'll just redraw the diagram like this. Okay, so we have 2 plane mirrors which is kept like this at an inclination. What is it? What is the inclination? The inclination given is 75 degree. Okay, 75 degree. M1 and M2. And incident ray is coming like this. Okay, coming like this. So, as per the law of reflection, what will happen? When an incident ray comes, it will definitely automatically reflect. So, the ray will what? Reflect. And I am going to draw normal. Finally, I will draw normal, okay? Just, I am going to draw normal. This is the normal to this plane, and this is the normal to this plane. So, I am highlighting with the red color so that you can understand the normals, okay? Now, what will happen to the ray? It will incident and it will reflect as per the law of reflection, okay? Here also the light ray will come and it will reflect. Normal case, incident angle, reflect. That is a law of, normal law of what? Reflection. Now let us mark the detailing. Here it is 75 degree and they told already it's what? Reflecting. The final angle of reflection is what? M2 with 30 degree. So what is 30 degree? Here it is 30. Okay. Here it is 30 degree. That's the final one. Okay. With the mirror M2. That is the question. Always whenever you approach a question in ray optics, always draw some diagrams, ray diagrams about it. Otherwise, it will be difficult for you to understand the question. If you draw that diagram properly, half of the problem is done. Make sure. Okay. So it is 30. And another thing, from here we can solve from back. Okay. If this is 30, obviously this is also 30. Why? Law of reflection. Angle of incidence equal to angle of reflection. Another thing, if this is 30, this is becoming a normal, right? If this is 30, this is also what? 60. 60 plus 30, 90 because it's normal. Another thing, if this is 60, this is 75, what about this angle? You just subtract 180 minus 75 plus 60, which is nothing but 45 degree. Okay? So we got this angle as what? 45. Another thing, this is the normal, right? So this is the normal. If this is 45, this is also what? Obviously 45. Okay? And so this question I am solving in reverse. Ray optics, many of the cases we had to solve in reverse. Another example I will tell you in prism. Many of the prism problem, those who are asking for what? JEE mains or advanced or like board exams and all, you had to solve from what? Reverse. You had to solve in reverse. You will definitely get answer. Okay? Read in reverse. So if this is 45, what about this? It's also obviously 45. 45, 45. I hope it is clear to you. Okay. So we got almost all the angles. But only we have what? This 75 and 30. From that, this many angles we got. Okay. But they are asking what? Total deviation of the ray. Okay. Actually, the ray came like this and it's going like this. So you had to find out the deviation. You know what is the symbol for angle of deviation we are normally use? You can use either the symbol of delta or you can use symbol of what? D also. Okay. Here I am going to use delta. So let us do in different way, two parts. Okay. There is a shortcut for this that I will tell at the last. First we will see the solution in detail. Okay. So I am going to extrapolate the straight. This is the incident ray, right? I am going to extrapolate. So the incident ray came like this and reflect like this. So what is the deviation? This will be the deviation. Okay. What is angle of deviation? It is the angle between what? Actual ray and whatever deviated ray, right? So this and this. Instead of going like this, it is reflecting. So delta 1 is the angle of deviation here. You hope you can see this. Okay. Another thing, the angle of deviation at this point, look at this one. The incident ray for this surface is actually extrapolate. You can clearly understand. Okay. So what is the incident ray for this one and reflected ray? So this become what? Delta 2. Incident and reflected delta 2. Actually they are asking what is delta 1 and delta 2. This is what they are asking. And you can see here it's a straight line, right? So the angle, total angle subtend will be what? 180 degree. So let me write what is delta 1. Delta 1 is equal to, so total angle is what? 180. 180 minus 2 into 45. That becomes delta 1. Very simple. Look at the diagram. Okay. Second case. What about delta 2? Delta 2 is equal to 180 minus. Same thing. 30 plus 30 and delta 2 altogether becomes 180. So it's nothing but 2 into, what is the angle? 30. Okay. So it's nothing but what? 180 minus 90. This is 180 minus 60. So what is delta 1 plus delta 2? Which is 180 plus 180. I'm just adding like terms together, okay? Minus of 90 plus 60, which is nothing but 360 minus, what is it? 150, right? What is the angle? 210 degree. Isn't that simple? Okay, so the final answer is what? 210 degree. There is another shortcut method for this. I'll tell. Actually, you had to write 360 minus 2 into 75. Okay. So it's an easy method to find out. Why I did not say this one means you should know how the diagram comes. So if it is MCQ, you can use this formula also. You will get the same. And here, you no need to even think about it. You no need to draw the ray diagrams, nothing. Because 75 is already given, right? So 360 minus 75, 2 into 75. That becomes what? 150, and you will get the same answer. This is another method of solving what? This question. Hope you understand this. Okay. You can go with this or with this. Both are correct. Okay. Just go through the ray diagrams. Okay, let's go to the another question of plane mirror, okay, which asks for a JEE. And two plane mirrors M1 and M2 are right angle to each other, okay, as shown in the figure. A point source P is placed at a distance A and 2A meters away from mirrors M1 and M2 respectively. The shortest distance between the images thus formed is, and take actually it is square root of 5, okay, square root of 5, which is equal to 2.3. Let us solve this. Let me redraw the diagram once again. That means two plane mirrors are there, which is M1. This is one of the mirror, and another mirror is kept down, which is M2. Okay, this is another mirror, and there's a point P. It's very simple. If you draw the diagram, half is done, I can say. So this P is what? At a distance A. A here, and this is at a distance double of A. Okay. Now let us see where will be the image. As per the, you know very well, in plane mirror, you know that U equal to what? B. So what you had to write? If this is the object for the mirror, at the same distance behind the mirror, you will get what? Image. So if it is A, behind the mirror means obviously here. So you will get an image, I1. I can call it as I1, okay. So what about this image? If this is 2A above, you will get the same below, right? For mirror 2. This is mirror 2. So 2A distance you will get below. So if you join those, you will get like this actually. It's like a triangle it forms, okay, right angle triangle. So like this. This is also 2A, this is A, and if it is 2A, what about this? This is also 2A, right? Okay, and this is 2A, what about this? It's like parallel, right? Very simple, okay, it's A. So 2A, A, 2A, A. You all got the dimensions of the triangle, okay? Just you have to find what? The hypotenuse. And another thing, what do you mean by shortest distance? It always be a straight line, right? So this image I1, this image I2, what is the shortest distance? Shortest distance is always what? Straight line. There is no other shortest distance. So from this image I1 to image I2, this distance only they are asking. Now you understood what to do. What we have to do? Okay, it's very simple. You have to find this hypotenuse and this hypotenuse. And both are having same, no? So one is enough. So let us do this one. This hypotenuse, you can call it as x. X is equal to root of, what is it? A square plus 2A the whole square, which is nothing but root of A square plus 4A square, which is nothing but 5. A root 5. A root 5, okay. So actually this distance also you have to calculate. So what is the shortest distance? Shortest distance which is equal to 2a root 5. So it will be like a root 5, a root 5, 2a root 5. And another thing, they already given the value of root 5 as 2.3. Let's substitute that. 2 into 2.3a. So it is nothing but 4.68. This is the answer. I hope it is clear. Okay. Just it's a matter of diagram only. If you draw the diagram properly, the answer is done. Let's go through. Just go through the solution. Let's go to the next question. Last question for today's session. What is it? Let's read that. A point source of light B is placed at a distance L in front of the center of a mirror of width D hung vertically on the wall. Okay. A man walks in front of the mirror along the line parallel to the mirror at a distance of 2L from it as shown in the diagram. Okay. The greatest distance over which he can see the image of the light source in the mirror is. Okay. So the man is walking away along this line. Okay, I hope you understood. He is walking along this line. So what they are asking, what is the greatest distance over which he can see the image of the light of the source in the mirror. Okay, which is really a tricky question. Okay, so where is the source? This is a source. Mirror is here, and the man is walking like this. Okay, what is the maximum distance he can view? Here also you have to take the help of ray diagrams. It's another, I can say it's a tricky question. Okay, let's do. Let me redraw the diagram. So this is what the distance D, and this is the source which is at a distance L. Okay, and here another distance is there. I can call it as H, where the person can see that image. Okay, so I can mark this length. What is this length? These two lengths I am going to mark. This is like what? Total 12, right? In this question is given 12. So it's like what? Half of the distance, it is L. This half will be what? L. Okay. Now I can draw like this. I can call this distance as what? This total distance D means it will be like D by 2. This is also what? D by 2. And this is L. This is also L. So I can create a small, I can see a small right angle triangle with the dimensions what? D by 2, L. And this will be some value like X. You call it as X. Okay. Next, again the same thing I am going to do here. See here. So the maximum distance means I can call like this one, and extrapolating. Okay, so here also L, this is also like what? D by 2, this will be like X. Okay, so L, D by 2 and the same dimension X. Here also same thing is possible. Here is what? It's like the D by 2, then this is L, this is that dimension X, and this will be like extrapolating. What we need is, what about this distance? This is nothing but what? D by 2. This is nothing but what? D by 2. We need this distance only. This is the maximum view he can see that image. Okay. So we have to get this distance alone. How will you get this? This is like L. This is what? L. Look at this triangle alone. Okay. This is L. This is L. And look at this dimension. It's like symmetrical, right? You can see a symmetry here. Okay. If this distance is D, what about this distance? It's obviously D. Okay. Look at the diagram. This is X, L, X, D by 2, and this distance is D. This is also obviously D only. Okay. So likewise, if you create a symmetry here over here, if this distance is D, this distance also like what? D. So you get, as per the symmetry, this and this you will get D. So what is the maximum distance the person can see the image means? This is the total distance, which I called it as H. So what is the total distance? Greatest distance. which is equal to, what is it? D by 2 is there. Here one D by 2 is there. And one D is here and one D is here. So what is it? Which is nothing but D plus 2D, which is nothing but 3D. So simple, right? Just draw and complete the diagram. As per the symmetry, you will get the answer. I hope it is clear. Okay. So the session 1 of some important JEE question, especially from plane mirror, today's session is over. For more further session, you had to like, share and subscribe. Today, myself, Archana, signing off. Take care.